huge round of applause for Adam.
Thanks, hello, hello. Hello, yeah, thanks everyone. Hi, so my name's Adam Koch, and I work on the developer relations team as well, like Sam. I'm actually based in Melbourne, so I am the only developer relations person based in Melbourne. I used to be in Sydney, and then before that New York, but I'm really happy to be back home here in Melbourne and working from the Google office. So today I'm going to talk to you about Android App Bundle. Who's heard of Android App Bundles already? Okay, pretty good number, good to hear. With the tagline here, ship optimized APKs from Google Play. So there's kind of a very practical part of this presentation, I guess, and that's just to use bundles. But then the kind of forward-looking feature, I guess, is the modularisation component, which hopefully some of you have had a look at already. But two quick things before I start. One is, unfortunately, my presentation doesn't have fireworks or a horn. That's why I wanted to go before Sam, but unfortunately I couldn't.
Press the button again if you like.
I should have added that. And the second thing is, I think someone asked before about instant apps, which is called Google Play Instant now, versus PWAs. I'm actually a huge fan of PWAs, so I work a lot with some of our team who work with developers on PWAs. But I guess my answer to expand on that, and it's also a non-answer like Sam's was, is that you know, we've got different teams at Google who are all working at improving the products to work better, right? And on the web side, you know, natural behavior is to try and make the web behave more like apps, like make it more app-like. So that's what PWAs are. And then on the Android side, you know, working towards similar goals, but instead of making apps more app-like because they're already apps, we're trying to make them more web-like. So be able to break things down into smaller chunks and deliver them kind of like the web does. So you know, we're not trying to tell you which solution you should use, but we're just trying to improve all the products so that there's good options available for you. So that's my answer, I guess, also a non-answer. All right, so what am I going to talk about today? What is the new app bundle format? It sounds like a lot of you are already familiar with that. How is it used by Google Play? Because it's a publishing format. Some tools around app bundles, the modularisation component, which I think is kind of like the more interesting part of it, I guess. And then the play core library, which is related to modularisation. Okay, so what is an app bundle, first of all? I think the most important thing to take away, if you haven't heard of it before, is that it's not an installable binary format. It's not a replacement for APK. APK is still going to exist. It's a publishing format, and it's been built for Google Play to use, but there's no reason why other publishers couldn't adopt this format as well, and we hope they do over time. So it's sort of, I guess like the idea is that we'll be the first consumer of this and others can adopt it if they want to. There's a few other notes here. There's some extra metadata to describe the targeting inside the app bundle. And the format itself, it's a bit stricter than APK. So with APKs, often people could, you know, it's just a zip file, so people could unzip it, make some changes, bundle it back up, and it would still work often. This format is more prescriptive in how it's sort of set up. And in case you're curious, the extension is just AAB, or Android App Bundle. Okay, so the internals, the actual file format, it's a zip file, just like APK. And inside the zip file, it's actually very similar to the APK format. We didn't kind of want to go and reinvent the wheel. And the nice thing about that is that it means that a lot of tooling that already exists to analyze APKs can be used for app bundles as well. Inside the app bundle, you've got very similar directory structure like in an APK. The notable thing here is that you've got this base module, which you see at the top. And then inside that, you've got things like your Android manifest, your dex files, your resources, and so on. The only differences are kind of noted here. Some of the files are compiled to protobuf format, which ends in a .pb extension. And that's just for easier usage down the pipe, so things like we can make transforms in the data quite easily. But otherwise, it's a fairly straightforward file format with all of the kind of components from APK that you're used to. So one of the big changes around app bundles was file targeting. So being able to make sure we know which parts of the app bundle inside it are for which types of devices. So you could kind of do this to some extent with APKs already. So hopefully you're familiar with like the resources directory and how you can target like a values directory to French or a drawable directory to XHTBI. So we're already reusing those components. but we add additional targeting for things like assets. So how does that work? Well, if you've got an assets directory and you've got some assets stored there, we actually use this sort of new hash format to actually target different assets for different types of devices. So there's an example there for language. Here you can see, so we've got strings, hash, and then lang, which is the type of resource, and then fr, which is the targeting, and then any files you want to target towards that particular type of device. Right now we support languages, but coming soon texture compression formats, and OpenGL and Vulkan targeting as well. Okay, so why do we go through all this trouble to create this new format? This is where Google Play does a lot of the heavy lifting based on this new format. So who's heard of split APKs? Not multi-APK, but split APKs. Okay, someone tell me what it is.
So
No?
based on your Gradle configuration, you can split out multiple APKs with various configurations. What I did.
Yep, spot on. And interestingly, the way it works, and it works from API level 21, so it's actually built in to Lollipop and above. The way it works is you can actually get these APKs and just load them one after each other, and they'll all combine together and be as if you installed just one big APK. So I don't know if you knew that, but a lot of people don't realize that that's kind of how it works on the system level. And the way it knows it's the same application is just the application package name plus the version is matching, and then it sort of combines these things together. And so if you use the build tools like Gradle to actually break apart your app into these splits, it allows us to combine different bits and reinstall them as if they were just one APK again. So it's actually a really nice feature that we kind of put into Lollipop and wasn't really widely used, but now it allows us to do these things back to Lollipop. Okay, so what does this mean? Well, we can take this app bundle, which kind of describes everything about your app, and we can break it down into these split APKs for you. So rather than using Gradle, like was mentioned, you can actually upload the app bundle, and we'll do this all server-side at Google Play. And we'll generate a base APK, and then for all these different types of assets, we'll generate all these other APKs as well. So there'll be like, your app, XXX HTTPI APK, XHTTPI, there'll be x86 if you have native code, there'll be FR, EN, these languages if you have different languages. So there'll be all these different APKs, right? And then, so we'll have these on Google Play ready to be served to users, right? And then a user comes along with, say, this device, Samsung Galaxy J5, which is set English locale, ARM CPU architecture, and XHTTPI assets, XHTTPI screen density. And what Google Play will do is it'll actually send down those APKs. So it'll send down the base APK, the English APK, the ARM APK, and the XHTTPI APK, and it'll just load them up onto the device, like together. And the result of that is just one installed app with just those components, right? And so, what does this mean in terms of, what effect does this have? Well, they don't have to go and download all those other assets. Now, this was kind of achievable in the past using something like multi-APK, but it was a bit of a pain. You had to go and build all these APKs yourself using your own build config and upload them all to Google Play yourself. And so it was quite complicated to do. And Play handles all this for you. So the user will just see one installing, it'll handle network connectivity, and all of a sudden the app will be installed just with those right components. Okay, so that's all good, but what happens on devices before Lollipop where split APK was not possible? So it was not possible to load these sort of individual APKs. So what we do on the Google Play side is we actually do something very similar to multi-APK for you. So multi-APK, who knows what multi-APK is? Okay, it's an older feature of Google Play, and it lets you upload multiple APKs to Google Play and have them distributed down to users based on their device config. But it was a pretty clunky process. So you would have to go and manually build an APK for each density, for each language, for each CPU architecture, and obviously you weren't able to do that for every combination because it was just too complicated. But if you really wanted to deliver down just the right bits to each user, that's what you had to do. Now, you don't have to do that. You upload one app bundle to Google Play, and we go and generate every combination for you. So you can see here in this sort of matrix on the right, we'll generate a binary, an APK for XXX HTTPI with Intel, we'll generate a binary for XXX HTTPI for ARM, and so on and so forth until we have one for every kind of combination. You'll note here that language is not included, and the reason for that is simply, you've got to multiply each one of these by the number of languages, so the number will grow very significantly at that point. And the space savings are not as much as drawable assets or native code. So that's how I handle pre-L and post-L. Okay, so if you want to give it a go, it's available already to try out. However, a prerequisite for trying it is something called Google Play App Signing. So I'm not going to talk about this too much today, but it is a requirement. Who's enabled Google Play App Signing? Okay, not many. So without that, you cannot try any of this, what I'm talking about tonight. It is a big step, kind of, I guess, moving over to Google Play App Signing. For those of you who aren't familiar with it, it means you hand over your released signing keys to Google Play to hold for you, to keep for you, and it lets us change the APKs and then sign them before delivering it down to the user. So it will have a lot of benefits in the long run because we'll be able to do these optimizations and then sign it on the way down to the user. Out of interest, does everyone know why we've moved to this Google Play App Signing infrastructure? Anyone? Yep.
Yeah, if you lose your keys, you can never release another update to your app.
Exactly right. And funnily enough, the #1 support request, I think the top 3 support types of support requests on Google Play is key-related issues. So I think it's, I've lost my key, what do I do? What can you do? Nothing. You have to create a new package. Or I've lost the password to the key, what do I do? Nothing, we can't help you. Or, I signed 3 apps with the same key and now the company's going to a different company and I don't want them to use the same key anymore. What do? Nothing. And so there's a lot of problems with, with us not holding the keys, whereas once we hold the keys, we just need to verify your account and we can always give you access again. So I highly encourage you to switch over to it at some point if you can. New apps in Google Play will actually prompt you to enable this by default when you start creating a new app.
Sorry, so that's unrelated to the new signing by Google Play to ensure the app can be Google Play for the countries where they have bad internet so that they can share the APK on a thumb drive. That's like a new security feature.
The metadata, adding the metadata?
I think so.
Yes, it's unrelated, yeah. That's right. Okay, so you enabled that, now you can try it out. How do you try it out? So use Android Studio 3.2, which is released at Google I/O. It's now in beta. And it's as easy as, instead of building your APK through the menus, you can just build an app bundle, and it generates an AAB file. And the wizard, everything just looks exactly the same. You can also generate from the command line using Gradle, no problem. Then you go to Google Play Console, and where you upload your APK, you upload your AAB. No different to uploading your APK. After that, we'll do everything else for you. So as you can see, once you have app signing enabled, it's actually really easy to sort of get started using this. We'll go and handle pre-L and post-L for you and handle all of those things I just talked about. There is some Gradle configuration, totally optional. If you leave this out altogether, we'll just split on all of those things that we have available. However, if you do want more control of it, you can add this DSL to your Gradle configuration. It just allows you to disable some of the splits if you want. As far as I can tell, I don't think there's a great reason to disable some of these. Density and ABI, I don't think there's a great reason. The only one you may think about is language. And the reason for that is some apps actually go and allow you to change language within the app. So normally apps use the locale set from the system device, and that works fine. But if you actually allow users to change their language from within the app, which some apps have a reason to do, if you split on language, when they change language, that language APK won't be available, right? And so you may want to just disable that and include all the languages in the APKs. And if you go to Google Play Console after uploading your AAB, there'll be a new Bundle Explorer tool, which is pretty neat. It displays, at the very top, it's got a percentage, so size savings for your users, an overall percentage of size savings, which is really nice to see like how much your users are actually benefiting from this. And it also lets you navigate the bundles that were generated. And it's really nice because you can actually go and search for a specific device, so Galaxy S8 or Pixel or something like that, and download the exact APK bundles that will be installed on that device. So if you're running into an issue and you want to test exactly as a user would get those binaries, you can go and get them from this. Okay, and to kind of complete the picture here, there's some tooling that's really useful, and that's something called Bundle Tool. It's a command line tool, and it's actually open source on GitHub as well, so you can kind of see how it works and go and try it out. And it really just has two commands. There's only two commands that it lets you do. One is build APKs, and one is install APKs. And when you build APKs, it turns into this file called APKs, or APK set archive, which is essentially just a zip file full of APKs. Let's have a look how it works. So here we just call bundle tool, and the command is build APK, so we're going to build some APKs. It takes an input of the Android app bundle, and it takes an output of the APK set archive that I just talked about. And then you can give it some signing configuration, so if you want to sign it with a key, you can. And then here we pass something called a parameter called connected device. And what this is going to do, it's going to look at the device that's plugged into your machine, and it's going to look at the specs of the device, and it's going to generate the APKs archive based on the device that's plugged in. So you've got a pixel in there, it's going to generate XX HTTPI, and English if I have English set on my device. Let's see how it looks. Yeah. And that means you now have this nice binary that you can actually use to sort of install into that specific device. However, if you don't have the device plugged in and you still want to generate a particular APK set for whatever device, you can also just pass in a device spec, and it's just a JSON file with the specs of that particular device. Okay, so you've got this APK set now, so it's got a set of APKs generated for you. And then you can call bundle tool install APKs, and it'll actually go and install the APKs onto the device through the APK set as if it was doing the same thing as Google Play. It'll open up that APK set, it'll pick out the right APKs and put them onto the device for you. And then the last thing worth noting is that it can also pass a parameter called universal, which will just generate basically an APK like what you're used to. It has everything inside one big APK. This is not as useful for accurately mimicking what's going to be installed on a device, but it is useful for maybe a test setup where you want to install it onto many different devices and don't want to be worrying about sort of all of the different ways that Google Play will distribute it. The nice thing about Bundle Tool is this is the same code that's running on Google Play. So you can be confident that what you see here and how this generates everything will be the same way that Google Play does it on the back end. Okay, so all of that, why would you want to do this? Well, first of all, as I said, it's pretty simple to do once you've got app signing enabled. And the best thing is it enables some pretty immediate size savings, so 20% or more in some cases. Obviously it depends on the makeup of your app, so what native code you have, what resources you have, things like that. If you're using multi-APK, or even if you're not, you don't have to deal with the complexities of multi-APK, which is quite an old feature of Google Play. And as new devices come out, you don't have to worry about their configurations. Like, we'll handle that for you by picking out the right APKs for you. Okay, so that bit I feel like is very practical, and everybody should really think about that for their apps. The next bit is modularisation, and I think this kind of I guess, sort of matches a little bit of what Sam was talking about, is we're trying to push the platform forward. Just like PWAs is trying to push web forward, this is trying to push Android native apps forward in a way that is sort of like improving them for the long run. And so you may not want to build this into your app today, but I think it's something you should really think about for the future of your app. So what is modularisation? Well, we're using the same features I just talked about, but instead of splitting by all these different types of assets, you're actually going to split your app up by features and functionality. So you can actually take out like the camera functionality and bake it into its own module. Or you can take out that cool VR feature that you built in and bake that into its own module. And then you can use all these split APKs I was talking about to actually load them on demand. So when a user wants it, you can get that particular module. The nice thing here is you can initially serve just the important parts of your app, and then on demand get these additional features as you go. So how do you decide what to modularize? I think these bullet points give you sort of an initial guide, but obviously it's up to your app and your choice. But a good example to start with, I guess, is features that only a small number of users use. So I can't remember who I was talking to, but yeah, I mean, they built an awesome like VR feature into their app. AR feature into their app. And the users that used it, they loved it. They thought it was awesome. But only like 5% of their users were using it. Yet every user has to go and download like 25 megs to get that particular feature working. So that's like a good example of something that could become its own module. Or it could be features that take significant space. Even if a lot of your users use it, it might just be worth having that as a separate module, which comes and gets downloaded later. And then lastly, features that users can wait for. There's a way to defer installation of these modules. So if your users aren't going to use it initially, like maybe it's a game with different levels or something like that, and they're not going to play level 5 for a day, you could download that later. Okay, so Google Play actually does something very similar to before, and it breaks everything down into these different split APKs. But this time, it actually does it all again, each module. So here we've got a base module, and then we've also got an add recipe module and a VR viewer module. So for the add recipe and the VR viewer modules, it's actually going to go and create all those APKs again. So you can just think of all the APKs that we're generating now for your app. It's going to generate a base APK, and then one for XXHTTPI, XHTTPI, so on and so forth, each one of your modules. And then when the user goes and installs one of those modules, it'll get the base, and then it'll pick off the right APKs again, just for that particular device. Okay, so now we've got the same problem again. What happens on pre-elp? Because we don't have the ability to pick and install all these APKs and combine into one. The way it works is you can set a flag in your configuration called fused. And what this does is it fuses a particular on-demand module into the base APK. So it combines it into one big APK again, picking out the right densities for you, and it serves that down to the user. You can also mark it as not fused, which means it just won't ever load into that user's app. And that may be useful for something that's on the latest version of Android, but not useful for pre-L devices, so it doesn't need to ever be downloaded. Okay, so you can go and try this out right now as well. Again, in Android Studio 3.2 or higher, there's a new module wizard which will actually set everything up for you. Or you can just go and modify things yourself. It's actually pretty straightforward. I removed the steps in this presentation today just because we don't have that much time. But it's really just modifying your Android XML and modifying some build.gradle configurations to sort of link the module with the base module. Okay, so that's all good, but you're probably wondering, well, how do I actually go and install this thing? Like, how do I get my user to install? Like, it's not going to just magically happen. How do I tell at which point in my app and all of that? And for that, we have something called the Play Core library, which is available now as well. And there's APIs in there that let you list out which modules are available, which ones are installed, which ones are not installed, and also request to have them installed. So use something called the Split Install Manager API. And this communicates through to the Google Play app on the device, and the Google Play app does all of the difficult communication with the Google Play backend. And so obviously you'll need to have a device with Google Play, and it needs to be on a fairly new version. It gets auto-updated, so it should be that way. Here's an example. I won't walk through it, but it's pretty straightforward. You create a builder, and you call install, and off it goes. Now, in some cases, you're going to want to have a UI to actually show the user the progress of the installation. So we have a couple of ways to do that. One is polling for updates, and one is listening to the status. And right now, you can just see if it's downloading, if it's installing, or if it's installed. But hopefully in the future we'll have be able to see the percentage of install, of download and things like that as well. Now if the module gets larger than 10 megabytes, we actually require the user to see a dialog and confirm that they actually want to install that. Alternatively, if you want to avoid that and you still have a large module, you can use something called a deferred install, which is quite a neat feature. It lets you install that module, but when the device is idle, so maybe at night when it's charging on Wi-Fi. Okay, so after the APK is being downloaded and installed for you, on Android N and above, nothing's required. You just need to refresh your context, and you'll have access to all those classes and all the resources. It's easy as that. On N and N devices, a restart of your app is required to get full access to everything. Alternatively, you can use something called split compat, which kind of works like the Dex loader to load in some parts of the app in advance. If you go to the docs though, there is a few caveats there, so a few things you can't use without an app restart. After the app gets restarted, it automatically loads everything for you. And then the question we always get is like, how do these things stay updated? You don't have to worry about this at all. Google Play handles it for you. So if the user goes and updates from Google Play, we'll actually go and download the corresponding modules for it as well and update those. If the user updates their app and then installs a module, we'll make sure we get the matching module for that particular app as well. So it's all handled seamlessly for you. Okay, and this is available to try right now. You can publish it out on the internal test track or alpha track. It's not available to launch in prod track quite yet. But try it out, give us your feedback. Really interested to see what people do with it. And you can find all the information here that I talked about at g.co/Android app bundle. And that is it. Thank you very much.